Okay, so this video is going to look at simple interest and compound interest values increasing and decreasing. So first of all, what is simple interest? Simple interest is where you get a fixed amount each year, no matter what is in your bank account after the first or second or third year. So say I have £100 in my account, and they tell me that I get a 10% simple interest. So that means I'll find 10% of my starting value. So 10% of 100, which equals to £10, and I will just get £10 every year. So after year 1, I'll have £110. After year 2, I'll have £120. After year 3, I'll have £130, and so on. It doesn't matter what I have in my bank account after that, I will just get the 10% of my starting value every single year. But when we talk about compound interest, this is where if I start with £100 and I get a 10% compound interest, well, in year 1 they'll find 10% of £100, which again equals to 10. So in year 1 I'll have £110. But then to calculate my interest for year 2, they'll find 10% of what is in my account at the end of year 1. So of £110, which is £11. So in year 2, I'll get that £11 added onto my account, so 121. And then for year 3, they'll find 10% of my £121, which will be £12.10. So in year 3, I'll have £133.10. There's a formula for doing this quicker, which we'll get onto in a few slides, but this is the basic idea of it. Simple interest, you just get the same amount from your first year constantly. Compound interest, you get a different amount depending on what is in your account at the end of that year. So let's have a go into some problems where the value appreciates, and appreciate just means goes up. There's a lot of technical terms in here that's important to understand. These questions don't use them so much, but you'll see appreciates and depreciates. You'll see different words used for years. You'll see the word annum used, which we'll see in a few slides. So, I want a bit of a line down the middle here, that's awful. Always take note if it's simple or compound interest, and that is the key thing for this. So we get 5% simple interest per year. We want to figure out how much we have after 2 years. So we start with £4,000 in our account. Simple interest, we just want to find 5% of 4,000, and we can do that by doing, well, you can find 10% and half it, that's probably the easiest way. That is going to be £200. And we just want to add that on twice. And we've got that twice from 2 years. If it was 3 years, we'd add it on 3 times, etc. So we want to do 4,000 plus 200 plus 200, that's year 1, that's year 2, and we get £4,400 in this person's account after 2 years at a simple interest of 5%. This time we've got the exact same question but with compound interest, and I've done it like this just so we can kind of see the differences between them. So we start with £4,000. We've already found out that 5% of 4,000 equals to £200. So in year 1 we're going to have 4,000 plus 200, £4,200. We then want to find 5% of 4,200. So I'm doing that by doing 4,200 times by 0.05, because that represents 5%. You can do it in a way where you find 10% and half it, that's completely fine. And that gets me £210. So year 2, we're going to have the value we've had in the year before, plus this new interest rate. So that's going to be £4,410. So that is what we'll end up with after 2 years. So you can see we've got a slight bit more money. This is going to keep going up and up by bigger increases. So if you are investing anything in any bank, compound interest is generally going to be better for you, unless you feel like you're going to get less money in your account over the years, which is not the idea of the bank. Okay, another set of problems until you're having a go at one. Sam invests £1,800, a simple interest of 4% a year. We want to find out at the end of 4 years. So, start with 1,800. We want to find, well, what is 4% of 1,800? I'm going to do 1,800 times by 0.04 in my calculator. And that is going to be £72. So I just want to add on £72 4 times. That is my amount of years. So plus 4 lots of 72, that was 4 times 72, and then I'm adding it on. So at the end of 4 years, after 4 years, we are going to have £2,088 in our account. If we think back to our method of the slide before, we kind of calculate the percentage each time. When we start looking at 4 years, that's going to be a lot of work and a lot of room for making a mistake. I'll do it that way, and then I'm going to show you a quicker way afterwards. So we start with £1,800. I want to find 4% of that. So 4% we've already found out is £72. So at the end of year 1, we've got 1,872. I've added these together. We then want to find 4% of 1,872. So I'm going to do 1,872 times by 0.04, and that gets me £74.88. So at the end of year 2, I'm going to add this and this together. And that gets me 1,946.88. I then want to find 4%, so you can see already how this is getting like a lot of effort and a lot of room for errors. And that gets me £77.87 and some decimal pence, but I'm going to keep it in there just for accuracy. So in year 3, I'm going to add this and this together. And that gets me £2,024.75.52. And then I'm going to find 4% of this number. I'm not going to write it out. And that is £80.99. And then, so in year 4, I'm going to add this number and this number. And that gets me to £2,105.75 after I round it to 2 decimal places, because whenever you're talking about money, 2 decimal places makes sense, because after a penny we've got no value of money there. So that's the long way we can do it. I'm going to rub this top bit out and I'm going to save this answer, and we're going to see if this new method we have gets us to the same answer. So if you wanted that down for your notes, you can always just rewind them for a couple seconds and pause the video. The beauty of this, doing it on a video, is if I rub stuff out, you can just go back and find it again. So, for this new method, which is going to make these so much easier if you can remember this, I'm always going to list out some key information. So the starting value, my interest, and my years. We want to do, so the new value is going to equal our start value times by 1 plus our interest to the power of how many years we have. And it's important to have the decimal of the interest. So the decimal, so 4% equals to 0.04. The reason we want to do 1 plus that is because we are increasing. So this changes for when we have problems that decrease and we put this to a minus sign. So this 1 represents the starting 100% of the value. If we just did 1,800 times 1, we just get the exact same number. This adding on interest adds on the 4% each time. And what this actually does is it does that repeated process of finding 4%, adding it on, finding 4%, adding it on, and it does it 4 times. So I'm going to put my values in there. 1,800 times by 1 plus 0.04 to the power of 4. That's how many years I've got. You can always, if you get kind of comfortable with this and you can think, well, I don't want to type that in my calculator. I know if it's a 4% increase, I want to say, well, 1.04. So if I type that into my calculator, times by 1.04 to the power of 4, and if you follow along, if you want to type it in your calculator as well, you'll see that I get 2105.75. So you can see I got the exact same answer, doing it both my ways. How much easier is this way though? How much easier is that? And the more you practice with it, the more you tend to remember it. And it made quite a lot of sense for me. Your starting value times by the new percentage that it's going to be. After 1 year, it's going to be 104% because we've increased it by 4. So you basically write what is 104% there. And you want to do that to the power of how many years. Okay, so I've got 2 problems for you to have a go at. And I encourage you to be careful of thinking, well, is it compound or simple interest? Simple interest, you just got to find it once and add it on. Compound interest, I'd encourage you to try and use that formula. Because it's definitely going to be the way to go. Okay, so pause the video if you haven't already. I'm going to do it in 3 seconds. Okay, so I'll start with my simple interest one. Again, you can see there's the same questions, but just slightly changed to be simple or compound. So simple interest, we want to find 3% of 800. That is going to be 800 times by 0.03, and that is £24. So then I want to do 84 plus 24 and 4 lots of that because of 4 years. So 800 plus 4 lots of 24, that is £896. And then if we were doing our formula method of this, we'd be here quite a long time if we were doing it the old method. We want to do 800 times by 1.03 to the power of 4. This little word annum, that just means, that's like the business term for year. So we've got 4 years, a 3% increase. So I just want to type that into my calculator. And I forgot to say the starting value of 800. So 800 times by 1.03 to the power of 4. So I get £900.41 once I round it. I'd have got 0.407. I'd have rounded that up to 41. And let's have a look at these depreciating value problems. These what you'll always generally see with compound interest problem solving skills here, not so much simple. And you'll generally see it with things emptying, so like a fish tank emptying, or the value of a car or something like that, or a games console that depreciates in value as soon as you buy it. They're not as good second hand. So a car was bought for £20,000, so my start value is £20,000. My interest, in this case, it wouldn't particularly be called interest, it's just a percentage change. And that's going to be 31% down, because we are depreciating. This means losing value. And for the amount of years, that is 4 years. So I want to do my starting value times by, so I write it out as well, starting value times by 1. If we're depreciating, you want to take away the percentage. So this would be 0.31 as a decimal, and we want to still do that to the amount of years. And I realised I've not written it out in words there. I've done it like I'm going to do in the line below. There we go. So 1 take away the percentage change this time. So 1 take away 0.31 to the power of 4. So you might want to simplify that to 0.69 to the power of 4. And we do that because once something decreases by 31%, the actual percent left of it is 69%. And that is going to absolutely decrease loads and take us to £4,533.42. That's gone down in a load of value, less than a quarter of it. Okay, and then same for this one. We're going to have to kind of think a little bit different here. So my starting value, well, that's not something we particularly know. I'm just going to call that F for full. What we lose, so my percentage change, is 12% down because it's leaking. And for instead of years, this would be hours, and it's 3 hours. So we're going to have the start value F times by 1 subtract 0.12. Remember, 12% is 0.12 as a decimal. It's the amount of years. Well, we just want to kind of calculate this section here. So I want to do 0.88, which would be this bracket, to the power of 3. That gets me 0.68 times by whatever our full value is. So we're taking our full value of the bucket and timesing it by 0.68. So that is saying, well, we've got 68% of the water left. So how much water is lost? Well, we've lost 32% of the water. That's just the difference between that and what it was when it was full. So a bit of a different question there. Not as common, but another application of it. So I've got 2 questions for you to do here. This is a more straightforward one, like my first example. This one you might just want to set up your formula and do a bit of a trial and error with the power you use for the amount of years until you get the answer you want. Okay, so pause the video. I'm going to go through it in 3, 2, 1, and I'm back. So my starting value times by 1, subtract my percentage change, which is 7%, 0.07, for 3 years. So I want to type that in my calculator. I can simplify that to 0.93. And I get 24130 and 71 pence. So £24,000, £24,130 71 pence. Okay, and then this one, okay, the starting value is 6,200. It decreases by 7.2%, so it's a difficult one to find. So 0.072 would be my decimal equivalent of that. So I want to times that by 1, subtract 0.072. Times by, well, we don't know what we want to times it by yet. And when we do that, we want it to turn out to be £1,000. So, first of all, I'm just going to convert that to be 0.928. So I'm going to type this in my calculator. And then I'm going to press that power key where I can change the value. And the number I put up there, that's going to be the amount of years. So if I just try after 2 years and let's see what happens. So I put power of 2 up there. That's going to get me £5,339.34. That's way too much. So I'm actually going to up it to 10 years. I'm just going to press left on my calculator, delete that 2, and put a 10 up here. That gets me 2,936 point something. Again, that's way too high. It's not less than 1,000. So I'm going to go to 20 years. And what I've typed for this one is, that's what I've typed. That's taken me still not far enough. So I'm going to go 25 years. By typing a 25 as the power. Okay, so that's taken me to this. That is less than 1,000. But I just want to check 24. Just to see, well, 24 years might have been the first year that tipped it below 1,000. And 24 years has given me this, which is not low enough. So the first year it went below 1,000 was 25 years. So 25 years is my answer for that. And then final question, hopefully this video has not been too long, an exam question for us. So this was on the paper last year, and it was towards the start of the paper, and it was 4 marks, so one we should definitely be trying to get. We put £2,000 into this one, and Ben puts 1,600 into this one. Both accounts pay compound interest. That is important. So we want to think, well, let's have a look at the cash saving account. Our starting value is 2,000, and we are increasing it by 2.5%. 2.5% is 0.025, so we want to times that by 1, because we're increasing in value, plus 0.025. And they're both going for 3 years. So we want to do that to the power of 3. So I'm going to type that into my calculator. Remember your brackets around this part, like I've literally as I've written it on the board. And when I do that, this person's going to get £2,153.78 at the end of the 3 years. Let's check the shares account. Well, they start with 1,600. They get a bigger percentage, so this is what could tip it over. That is going to be 0.035. So 1 plus 0.035 again to the power of 3. So I'm going to type that into my calculator, and this person is going to get nowhere near as much money actually. £1,773.95. So cash saving, and that is Ali. Ali gets more money. Oh, sorry, it says who gets the most interest. Okay, so Ali would get more money, but they're not concerned about who actually has the most money, just because Ali's put quite a considerable amount more in. So when you're asked for kind of just who has the most interest, you only care about the extra money they've got. So we want to do what we've got now, take away our original. And that is £173.95. That is just the pure extra money he's got. And then we can probably see easily from this one that that's going to be £153.78. So in fact, even though Ali has more money at the end, Ben is getting a larger interest or extra money. So Ben gets more interest.